My name is Darren. I'm a senior principal design engineer with Intelsat, and I'm joined here by Ohad from Cisco, from Cisco CX, who's helping us in this automation journey. So a little bit about Intelsat for those who might not be familiar with us. So Intelsat is the world's largest satellite provider of satellite-based communications. As a service provider, we offer a number of managed services in the following sectors. Historically, we've been a wholesale megahertz company, so essentially, you're buying or you're leasing space segment from us, or you're buying space segment from us, and we're providing a number of managed services for a number of end-to-end applications. Recently, we switched to more of a wholesale megabits product. As kind of demand for bandwidth has increased, demand for more flexible and dynamic services have increased, we realized the need to switch to offering more flexible megabit strategies for our end-to-end services. So as part of that communications infrastructure, we operate a global IPMPLS terrestrial backbone, and this is really what complements the space fleet. So essentially customers downlink to us, they're either coming as part of a platform product or as part of SCPC or MCPC satellite product, and then they're mostly going to a number of our POPs around the world for connection to their data centers or connecting their data centers, or even hand off to other partners. So we have a number of partner relationships with individuals like BT and PCCW who help us extend to regions where we currently don't have reach. So I'm here to talk today about our automation journey, and the spoiler alert here is that we're currently in the automation journey with Cisco. Let's say we're about 4 to 5 months into it. So I'm really here to share kind of how we started the journey, some of the challenges that we faced, a little bit of a deep dive into some of the use cases, and really how we're bringing in the user adoption for NSO in this initial release for us. So that's kind of, this is the long road, right? This is kind of where we started. We really didn't know where to start. There's a larger OSS transformation that Intelsat is going through right now. I'll explain a little bit about it next. This is kind of where we are now. That's not, hitting the head on the keyboard. That's like sleeping at the keyboard, because we're tackling a lot of long nights trying to get this to the release. And then hopefully this is the finish line, right? We're really looking to be victorious in here. It's been a pretty amazing journey so far, but I'm pretty sure this will be our face at the end. So, like most of the speakers from yesterday and today, right, our organizational target was really a transformation, and that was automated end-to-end service delivery. So we realized a lot of gaps in how our services are getting to market, the time to market for services, realizing new products was really taking quite a long time. So we have a much larger transformation in our OSS BSS, and this is kind of the typical model that a lot of folks that show that kind of summarize it here. And the approach that we took was basically there's a whole refactoring, if you will, of our OSS BSS. We're introducing a workflow and process automation layer, service orchestration. There's a number of network management systems for our platforms and our modem architectures to consider. Controllers, of which we have existing, as well as some that we're going to be adopting. And those can be SD-WAN controllers. There's some segment routing controllers that are currently in the mix. And there's obviously the Intelsat One infrastructure elements, like I mentioned in the previous slide, and that's our a combination of our IPMPLS terrestrial infrastructure, anything else that's on the ground, routers, switches, modems, our hub platforms, and whatnot. And then on the bottom is obviously our products and services. So this is the approach that we took basically before we even started on the whole journey, not just for service orchestration, obviously, which we're focusing on today, but really we wanted to introduce a new team culture, introduce the concept of service modeling, and then really focus more on end-to-end reliability. So if we zoom in a little bit further for the team culture, right? The folks running the ground infrastructure are really vertically integrated. Like most of us, CLI engineers, a lot of hardcore skill sets, CCIEs, GNCIEs, things of that nature. So we wanted to adopt more of a software-driven automation first mindset. We really wanted to define the network and service intent, really giving the wishes of how the network is to perform rather than just kind of going at it, and then adopting the infrastructure as code model. So that led us into a more of a service modeling approach. We wanted to define a contract language so that language can be used and can be inherited by OSS, BSS tools and their other northbound systems, who might benefit from it. We wanted to abstract the configuration and then obviously standardization, right? There was a lot of static documents and multiple variances of our services is to be provisioned. And then finally, end-to-end reliability, right? So really focus on assurance, and that's kind of, orders down, fault and performance up type view here on the left. End-to-end testing of everything, repetitive testing, back into the whole CI/CD infrastructure, and then compliance reporting for all of those services. So I won't read through all the objectives here, but a lot of the ones have been mentioned already. The gentleman from Orange, I think, touched on a lot of these as well. We really wanted to reduce the technical debt, which we had considerable amount of, surrounding service fulfillment and service assurance, eliminate a lot of the static documents and templates that we have that really drive the infrastructure configuration. We wanted to address personnel shortages and reduce vendor skill set fragmentation. That's obviously a big one for us, and I think for a lot of folks, because when you're coming into a new network, very multi-vendor, a lot of different platforms, there's obviously the skill set fragmentation of, Juniper guys and Cisco skills, and then obviously we have our the satellite platforms to worry about. So there's a lot of different multi-vendor environment to consider. We're preparing for scale and virtualization and cloud. That's a lot of part of the wholesale megabit strategy for us. And then most important is improving the responsiveness to the Intelsat business units. Again, reducing the time to market, reducing that provisioning life cycle that we currently spend weeks on at times. So the focus of today is going to be Cisco NSO, and that's where we filled in for the orchestration layer, right? So skipping ahead, obviously, through RFPs and evaluations of products, we came to Cisco NSO for the orchestration layer, and obviously for to fulfill the service modeling layer of the approach here in the middle. So the initial delivery for NSO, this is kind of a very high-level view of what we went through, right? So we started out with the technical proposal, and that's defining the use cases and scope. Then there was the organizational proposal. So right after we kind of pitched the technical view for NSO as a service orchestration layer, we then said, okay, how do we support this long-term? And how do we engage the existing team of network engineers and few software developers to start adopting that skill set, getting into the CI/CD mentality, really getting into the software development approach, and changing the mindset into more of a service modeling. So there was an organizational proposal that took place right after the technical proposal to say, hey, maybe we should spin off of the network engineering organization and kind of, figure out how this is going to be, how the culture is going to change and how we're going to support this long term. That then turned into the business case for us, and that's kind of the budgets and headcount area, and then the implementation and demonstration portion for service orchestration. And I added this yesterday after the presentation from Cisco. This is kind of we're in the cook along with Cisco method, and then obviously the user and service adoption. So for us to kind of to preface the next couple slides, the user and service adoption for us is actually at the CLI level to begin with. We're really focusing on the internal customer base, that being the NOC, operations, service provisioning, and core infrastructure engineering to use NSO right now. Obviously, once we've developed more of the OSS and BSS layers, developed more of the workflow layers, kind of the business processes and business workflows, that's where we would bring in more of the customer-facing portals, and kind of the whole workflow top-down process. So that is our sponsorship. That basically those three, as you would imagine, took the longest time, and that's really where we got the sponsorship. We wanted full sponsorship from the management team, from the executive teams, from operations, from the various network engineering teams, and really wanted to get that buy-in and get that belief, before we went forward with it. So in terms of the implementation, that line kind of, vaguely represents where we are today. Like I said, we're about 4 or 5 months into the engagement. So in terms of the infrastructure use case scope, what we really wanted to target was a day 1 through N. This is a very quick highlight. I won't go through all of these, but a very quick highlight of our P and PE targets for the NSO initial delivery. Obviously, there's different PEs which serve different functions in our network and serve different platforms or Intelsat products. And then for the product use case scope, this is a subset of the end-to-end product, but essentially, so Intelsat doesn't directly sell wholesale, let's say Ethernet private line or wholesale Ethernet private LAN. The end-to-end product for us includes all of the IF and RF gear that's involved in the satellite transmission, any modems or any platforms, just potentially other systems that are along that chain. So to get NSO in as a minimum viable product and help specifically a certain organization within the service provisioning organization itself, who are focusing on the IPMPLS terrestrial transport, this is where we really focus for the product use case scope. So it's a subset of the end-to-end products, but really what we targeted here was these 4. So, a lot of individuals have mentioned these today, right? Ethernet private lines, Ethernet private LANs, L3 VPNs, and kind of direct internet access. And the sub-bullets below them are really subsets of our private line and our trunking products for Intelsat. So before I go into some of the more detailed aspects of the use cases, Ohad is going to come here and speak in terms of the Cisco CX engagement.
Thank you, Darren. Hi everyone, my name is Ohad. I'm a software architect with the Cisco CX team, delivering automation on the Americas theater. And when I first met Darren in November last year, we defined 2 main goals for the project. The first one is the obvious one of delivering successful service packages for NSO for the various use cases that we saw in the previous slide. That's the obvious one. And the other one was helping Intelsat adopt automation. And we did that in two levels. The first one was the work that Darren and myself did with analyzing the services, not just on the configuration level and building, deriving the service attributes and defining what are the data types and building the Yang model, but also identifying what the overall flow is. And if there are steps today that are being taken by the users that are manual and can be automated, let's maximize the automation and reduce the manual labor to a minimum. So that's one level. The other level is that throughout the past months, whenever we delivered a service package that was ready for demonstration, Darren took that service package and introduced it to his team, running an internal demo within Intelsat. And by doing that, we achieved 2 goals. The first one was to introduce NSO and the automation concept to the team and have them get used to the idea of this is what you guys are gonna do pretty soon, get used to it and forget about the manual work that you've been doing. And the other one was getting feedback from them, actual technical feedback on the service implementation, enabling us to do some fine-tuning on the services before we go to production. And the second level in which we are supporting Intelsat with automation adoption is on the technical side, which is helping them building a Jenkins pipeline, adopting the whole CI/CD processes, having a source control system in place, triggering automatic deployment, automatic testing in their lab servers. And talking about testing, another big deliverable that we have in this project is the test automation. We took the robot framework with the library, which was formerly known as Rasta and now is known as CXTA or Siesta. We took that, we built a framework specific to Intelsat in a way that everything is templatized, so that whenever Darren and the team or even Cisco, while we're still engaged, are adding more tests to the test collection for the service packages, it's as easy as 1, 2, 3, like 3 steps to add a couple of XML templates. Once the templates are in place, just push as many input files as we want and have that framework handle the rest, including reporting, side-by-side comparison with color coding of the differences between the expected and the actual result. And as far as the service implementation goes, we automated various use cases, a total of 12, where we have 12 service packages that are customer facing And in addition to that, we have 13 more service packages that are resource-facing. We took a stack service approach for the infrastructure side of the project, where we the first use case took us some time to build, but then the remaining 7 was really quick to implement because we just reused the same service packages over and over again. One thing, talking about automation-oriented mindset, we saw that Intelsat are using spreadsheets to manage VPN IDs, map IDs, and other customer lists and things like that. And those spreadsheets are, to say the least, are unreliable, right? We don't want them to keep using it if they have automation. And we know that Intelsat have a plan for an inventory system to be adopted in the future, but we wanted the users to get used to the fact that they're not using spreadsheets anymore, even if that inventory system is not in place yet. So what we did is we built a small Yang model, we loaded that into NSO CDB, and that's where we're storing all the map IDs and VPN IDs and customer names and so on, so that whenever a user is provisioning a new service, the service code pulls that information from CDB at the moment, and in the future, once that inventory system is in place, it will be easy for Darren and the team, or for Cisco, if we're still there, to modify the service and to pull that information not from CDB, but rather from the inventory system. We have some other deliverables in this project, including TACAX integration with NSO, so the users are logging with the TACAX username and password, as well as high availability, where the 2 NSO nodes are geographically remote and also reside on different subnets, where we have a load balancer, an external load balancer handling the virtual IP between them. And that's pretty much a summary of what we're delivering this project from CX perspective. There.
Awesome. Thanks, Ohad. So getting into the 2 use cases, so the challenge here for NSO was really realizing day 1 through N infrastructure as a suite of services. So before kind of show all the graphics here, when we say suite of services, right? The approach we take for infrastructure today, a new router is coming up. We're replacing our core router. We have to implement a number of provider edges in a new location. We're bringing up a new POP in some portion of the world. It's the traditional, as you would imagine, right? We're referencing a configuration document of some kind. We've made some archaic attempt at variable abstraction, and the engineer is kind of filling these in and putting it on the device and doing their own verification. And it's a lot of intimate and intrinsic knowledge that goes along with it. So this was one of the bigger challenges for us in terms of the ongoing adoption. Like I said, we're currently in the project, going through a number of demos and really bringing the engineering and operations teams up to speed. In terms of the first thing we said to them was, when the infrastructure comes up, we want to present the infrastructure as more of a service. I know that sounds strange right now, potentially in terms of, hey, the infrastructure is not a service, it supports services, but we wanted to really change that mindset. So we took the day 1, or the day 0 through N approach, and this is a combination of a homegrown solution for zero-touch provisioning along with NSO. Again, the NSO challenge being specifically the day 1 through N. So for day 0 for us, right, which is the day 0, for most I would imagine, is any images and minimum configuration required to establish communication between the network element and NSO. So literally, the box, they will have a device physically in a box, a new router, whatever it may be, and we need to get, our verified images on the device and some minimum configuration so that service orchestration system, such as NSO, can push the actual day 1 config. So in day 1, infrastructure configuration, and this is respective to the Intelsat device function, essentially gets pushed from NSO. And quick blurb right here, like Ohad mentioned, this was a little bit of a learning curve for myself too. So when we showed our requirements to Cisco CX, Ohad basically took a little bit to look at those and said, hey, I think you'd really benefit from a stack services approach in NSO, where your device functions, as there are many, can be the customer-facing services, and then all the individual things below it would be the resource-facing services, so they can be reused accordingly, like Lego blocks. So The resource-facing services was really where we spent a lot of the time in terms of honing in on, the standardized ISIS configuration, BGP, service policies, RSVP traffic engineering, right? We do a lot of MPLS TE for our services. There's a lot of 3.9 and 4.9 and 5.9 services that Intelsat provides. So there's a lot of traffic engineering and service policy and QoS components that go involved. All of those were really built as RFS. They were not facing the user. Once we had those kind of finalized, we started building the CFS infrastructure, and like Ohad said, that's where we really saw the flexibility in NSO, right? So whether it's a core router function or a provider edge for our border or a provider edge for our platform, we were able to just say, okay, well, this function also has BGP, and this function also has BGP, and we kind of just put the RFSs accordingly, and they really started to come along much quicker once the RFSs were delivered. And then day 2 through N, obviously once we have pushed the day 1 configuration through NSO as a service, we want that lifecycle to continue as a service through NSO. So again, this a lot of this is related to process and internal process workflow and adoption. But really, we want the configuration changes via modification, perhaps to NSO service models or templates push to the device. So the service delivery workflow ensures that all of the changes are funneled through NSO, and the infrastructure itself can continue to live as a service within NSO. So there's a little graphic here that I'm going to play, but this is really the template for it. So again, network engineer physically deploys network element, connect to an existing network and power up. This is a cadence that we're actually following right now. So network engineer configures a DHCP server with attribute identifying the network element. So essentially we built the front end. Again, this is all homegrown at the moment. We built the front end for our zero touch provisioning. An engineer can whitelist it by a serial number, by a MAC address, whatever the case may be. This is perhaps remote hands or some deployment engineer who's actually out in the field for us connecting it. We're essentially instructing just connect the power, connect management to it, and off we go. So once we've entered that into the system generates relevant DHCP, configuration files, any other scripts that goes along with it, and images. This whole process I won't go through, right, because this is a whole ZTP process, but at the end of it, we've essentially realized day 0. The device is now day 0 ready. So whether we've staged it at our site and then shipped it out, or we're doing it actually at site, like I said, with remote hands, we have now a device capable of day 0. At the end of this day 0 process, after ZTP is successfully completed, the process moves to NSO automatically to apply day 1 configuration. So essentially, this is adding the network element to the NSO database, and then a service transaction in which we apply the configuration to the network element based on that device function. So there's, again, calls within this homegrown system, adding NSO to the database, or adding the device to the NSO database, and then accordingly pushing the day 1 config. So, going 3 slides back, if it's a core router, the system is instructed that it's a core router, it makes the relevant calls to NSO, calls the core router CFS, the CRT CFS, and then pushes that day 1 configuration to the device. So this is, in summary, was our infrastructure use case. And again, this is 100% infrastructure. This is before customer services are onboarded, and really helping our core infrastructure network engineering team, who today has to go through a number of steps to both, upgrade an image and remember, Cisco image versus Juniper image or whatever the platform may be. And then obviously not having to worry about necessarily a lot of the details that are involved in some of the RFS protocols like ISIS and so on and so forth, but rather just calling that function. Oh, this device is a core router, this is a border router, push that function from NSO, and all of the attributes, minus the variables they have to input into the CFS, are sent down to the device. So the demonstration that we did on a recent deployment actually decreased the time required to realize day 0 and day 1 on a network element by approximately 91%. And this was actually timed in such a way where we were going through a pretty large refresh right now, as others are. So we're refreshing a lot of the terrestrial backbone, core, and edge at the moment, as part of a 5 to 7 year cycle refresh. And essentially, it's a lot of devices, right? I mean, we're talking, constantly getting shipments in and then having to go out. So we've been able to realize this for our recent deployments, and we've been able to cut that time down by 91%. So customer service use case overview, like I said a few slides back, we really targeted our private line and trunking service components, but right now just the IPMPLS provider edge to provider edge instead of the whole subset. So this is kind of a macro design view of the Intelsat ground infrastructure along with the satellite fleet. So we have our points of presence and our teleports. Obviously in our teleports, as we're closest to the satellite infrastructure there, we have various modems, various satellite hub platforms, and then provider edge routers, core routers, and so on and so forth. That in general complements the IPMPLS terrestrial infrastructure, which we call Intelsat 1. Then there's a very large satellite fleet, which essentially uplinking and downlinking into those teleports. And then the products and services and customer end-to-end applications, right? So this is, again, a very macro view of the Intelsat infrastructure, and where we approached this was the private line and trunking service components, essentially just IPMPLS provider edge to provider edge, and with NSO, this is the target for the customer service use case. So essentially, orders would be coming in, and for these products, now the service provisioning team, who are currently going through the adoption at the moment and currently going through the demonstrations at the moment, is versus having to go through a very large number of provider edge touch points for just one customer, sometimes in the upwards of 16 network elements. We have one service that's over 23,000 lines of raw Cisco IPMPLS configuration, right, across 20 plus network elements. So this is now where they're pivoting to NSO, if you will, and using NSO service models to provision those services via that single pane, via that central service orchestration, without having to exclusively log into each device. So the challenge for the customer service use cases was really a multiplex physical uni on Intelsat 1 provider edge. So if I can explain this a little bit, so imagine, if you will, we have customers downlinking and there's a modem receiving that at one of our teleports, right, like in the previous diagram. That customer has the ability to offer multiple services through that one physical uni, potentially on the same space segment. So with that one modem, perhaps the customer is saying, okay, I want 2 EPLs from here to here, and I want 1 EP length from here to this 8 locations, and I want a layer 3 VPN from here to here, and I also want to consume direct internet access because I want an exit point to the internet for the services that he's providing his customer. So there's a lot of things that have to go into play there, right? And Ohad and I took a lot of time in designing this approach because essentially, the uniqueness of each service is not just the customer and service ID, but potentially the customer, the service ID, and the VPN ID. And they can't overlap, and there has to be unique VPN IDs, and all of those fun things, right? So that was really a challenge for us, was the very top of our circle when we approached Cisco CX and showed them our environment, was really the multiplex physical uni. Anything that we do at the provider edge, whether a customer is buying 1 gig port from us or 10 gig port from us, the ability that we're offering the customer is those multiplex services, so they can realize any number of Intelsat products on just one physical port, if that need be. So if we bring up again the view of the Intelsat network, right? We've kind of zoomed in, or we've zoomed out of the Intelsat backbone up here and kind of showed a little bit more of the POP teleport with the devices, and then the rest of the Intelsat 1 backbone on the other side. And behind it, the rest of our POPs and teleports, our customer data centers, our data centers, so on and so forth. So with this multiplex physical uni, really we needed to realize multiple network services per uni, per customer, spanning multiple Intelsat products. So we did not take the CFS RFS approach for NSO in this one. We basically have built individual service models, but those service models have a lot of checks and balances for that core concept of the multiplex physical uni. So we're checking uniqueness for VPN ID, we're checking that the encapsulation attributes are unique per that port. We use a combination of L2 transport type ports, pseudo wire classes, layer 3 routed sub-interfaces natively, and a whole bunch of, amalgamation of technologies on one physical port to realize the fact that we can have multiple services and multiple sub-products on that physical port. So if we zoom out, or if we zoom in here, these are the 4 customer service models that Cisco is currently building for us, and we can now realize all 4 of these models, multiples of all 4 of these models on the same physical port. And in fact, we took a recent customer use case and demonstration just a few days before we came here, and basically using an existing customer who has probably 5 or 6 different EPLs, 2 or 3 different EP LANs, a number of L3 VPNs, and then 2 DIAs on that same physical port connected to one modem. And that's not just at the teleport side, that's the case also on all of the provider edge. The customer's data center is connected in a few locations. They also need that same flexibility at the port level at the handoff to their data centers. So we've been able to realize through that through NSO what originally had taken that customer to provision all those services about 2 weeks or so, it took about an hour, and that was really most of the time spent in gathering all the resources, VPN IDs, and the rest of the logical resources that go along with the service. So the adoption has been going really well internally. So that's really it. I think in summary, we've had a pretty fantastic engagement with Cisco CX. We really see the value in NSO. The teams are really starting to see the value. I think the longest tent in the pole for us was that sponsorship, was that getting that adoption internally, and then obviously technical on the ground, really focusing on the service creation, and then bringing it back to a lot of the stuff Ohad mentioned that they're helping us with, right? The test automation framework, that's a big one for us, right? We want to continuously test every time we change a service variable, every time we change a template. We want to go through the whole testing phase, and we have the dev, the UAT, the production environments, and a number of virtual and physical devices that we can use to test this stuff continuously. So we're really focusing on the CI/CD infrastructure right now. That's that's really the next big milestone. Before we roll out into production, getting the user adoption, getting users familiar, with how they're going to use NSO in its current phase, building a lot of the process workflows and the delivery models around NSO. That's it.
All right.
Cisco, the bridge to possible.